Welcome to your weekly AI City Update. Don't forget to subscribe for more AI updates.
Today, Alibaba open-sourced a model that is genuinely interesting for one reason. It is called Qwen3.8-Flash Next. It is 125 billion parameters, but it only activates 6 billion of them on every single token, and it is meant to be the architecture preview for the next Qwen generation. The headline claims are enormous. Better at coding, better at agent work, faster at 1 million tokens, and dramatically cheaper to train. The catch is the part that decides whether any of it is real. As of the day I checked, the production cloud version advertised as a built-in million-token context and official tools was not actually available to buy anywhere. So the whole thing is a promise with no way to test it yet. On the 26th of August, Alibaba released the weights for Qwen3.8-Flash Next on Hugging Face and Model Scope. The official blog calls it an early preview of the architecture that will be used in the next Qwen family, the same role that Qwen3 Next played before Qwen 3.5. In other words, this is not just another Flash refresh. It is a look inside the engine Alibaba intends to build the next generation on. If you build with coding agents, if you run a large codebase through an agent, or if you simply watch whether cheaper, more efficient models can reach the level of the expensive frontier ones. This is the release to understand this week. Before the numbers, you have to separate the two names because the coverage blurs them. Qwen3.8-Flash Next is the open weight release. It lives at the Hugging Face id Qwen/Qwen3.8-Flash Next, and it is the architecture preview. Then there is Qwen3.8-Flash No Next, which is the production cloud version built on top of the same weights with 1 million token context by default and official built-in tools. The open card literally says that. So one is the open research cut, the other is the served product. This episode is really about the product and about how much of the product is available right now. Here is the technical core. The model is a mixture of experts. 125 billion total parameters, but only 6 billion active per token, plus a 51 billion token engram embedding and a 4 billion multi-token prediction head. The interesting engineering is in the attention. Alibaba pairs gated DeltaNet with a new mechanism it calls Qwen sparse attention, block-level sparsity. It adds a gated residual branch, an engram embedding, and a training recipe mixing muon with AdamW, the company's own framing, is that this unlocks the efficiency that makes a big model cheap to run. That is a genuine engineering story, and it is worth watching even before you judge the scores. But note the language, this is Alibaba describing its own design, and the efficiency and capability framing is a company claim, not an audited result. Now the scores, and I want to be precise about what these are. Every number here is vendor reported. Alibaba runs the benchmarks, reruns the comparison baselines itself, and publishes the table. On agentic coding, it reports Deep SWE 1.1 at 58.7, SWE Bench Pro at 62.5, and SWE Bench Multilingual at 81. On general reasoning, GPQA Diamond at 91.7. On Vision Real-World QA at 88.5. Those are strong numbers, but read the footnotes and the picture gets more careful. Two of the agent benchmarks, Co-work Bench and Recreation Bench, are Alibaba's own in-house benchmarks. On Math Vision and Charziv, the model's score uses a fixed formatting prompt while, as the note says, other models get the higher of 2 runs, a methodology choice that favors the home team. And the comparison baselines, DeepSeek and Claude, were rerun by Alibaba, not taken from an independent leaderboard. None of this makes the model bad. It means the honest reading is, these are company claims awaiting independent verification. I found no independent benchmark with a visible methodology for this model yet. Here is the most useful single line in the table. On humanities last exam, the hard reasoning benchmark many labs treat as a ceiling test, Qwen3.8-Flash Next scores 35.9. And the table itself lists Claude Opus 4.6 at 40.0. So by the vendor's own numbers, on the hardest general reasoning task, this impressive cheap model lands meaningfully below the top frontier model. that is a good reminder. Cheap, efficient, and excellent at coding and benchmarks is not the same as genuinely frontier-level general intelligence. Alibaba does not hide this, which is honestly to their credit, but it is the number that should shape your expectations. The other headline is long context and speed. On the open weights, native context is 262,000 tokens, extendable to 1 million via Yarn, a rope scaling method you enable yourself. The production cloud version claims a built-in million-token context. On speed, Alibaba reports its sparse attention kernel gives up to 7.6 times prefill and 4.9 times decode at 1 million tokens, and with a 90% cache hit, 8.6 times the prefill throughput of the previous Plus model. Be careful, those are self-reported engineering figures, not independently measured. And there is a real warning in the card itself. Open-source frameworks implement Yarn as static, and the vendor says enabling it can hurt performance on shorter text. Long context is powerful, but it is not free and not automatically clean. Now the price. The launch announcement says the production Qwen3.8-Flash is priced at $0.16 per million input tokens and $0.47 per million output on Qwen Cloud, with the note API coming soon. That would be genuinely aggressive for a model this capable. But here is the discrepancy you need to see. When I pulled up the current Qwen Cloud pricing page, Qwen3.8-Flash was not on it. The canonical page lists the flagship Max at $2 in and $6 out, and the previous Flash line, Qwen3.7-Flash, from 3 cents to 20 cents in and 13 to 80 cents out, tiered by length. Qwen3.8-Flash simply is not listed, so the announced price is a promise on the blog, not a live line item. Do not quote it as current pricing. And that is the core problem, and it is a real one. The model everyone is excited about is Qwen3.8-Flash, the production version with the built-in million-token context and the official tools. But when I searched the Qwen Cloud model marketplace, it returned 0 results. The blog said API coming soon on release day. So as of the research date, the cloud model was not available to call. You cannot buy it, you cannot hit an endpoint. There is no confirmed model. What you can actually run today is the open weight next cut. But that is 125 billion parameters plus a large embedding, which needs serious GPU memory and in practice heavy quantization. To be direct with you, I could not run this model because the hosted API was not live and I do not have a GPU here that could load the open weights. That is why this is a launch analysis, not a fully tested review, and I am not going to pretend otherwise. Which raises a fair question: why ship the weights and the benchmark table before the cloud API is actually ready? There is a sensible reading. Alibaba wants the developer community to start using, fine-tuning, and evaluating the open model immediately, and it wants the architecture adopted before the full Qwen4 family lands. Releasing the research cut first, then the served product, is a deliberate rollout, the same pattern it used with the next line before. So this is not a broken launch. It is a staged one. But it does mean the thing you can hold and measure today is the research model, not the product that the pricing and the million-token claims describe. Let me be honest about the gaps, because they decide how much weight to give this. First, I found no independent benchmark with a visible methodology for this model. Every number is Alibaba's own, and 2 of the agent benchmarks are in-house. Second, the published card carries no dedicated safety card, no hum benchmark numbers, and no usage policy detail beyond the community license. That is an absence, and it matters for anyone thinking about putting this on real work. Third, there is no confirmed cache pricing and no confirmed cloud model ID, because the product is not live. And fourth, the exact long context behavior at 1 million tokens is claimed, not something I could verify. These are not reasons to dismiss it. They are reasons to treat the numbers as provisional. So who should care right now? If you build or fine-tune open models, or you run your own inference, the open next cut is worth a look. But expect to need serious hardware, and expect the numbers to be Alibaba's claims until you verify them yourself. If you use a hosted API in production, there is nothing to use yet. Do not redesign around Qwen3.8-Flash until the cloud model actually appears and you can test it on your own workload. If you are just watching the market, the architecture is the story. 6 billion active parameters delivering near-frontier coding scores is exactly the kind of efficiency that pushes prices down across the whole industry. My verdict on Qwen3.8-Flash: as a paper launch, it is a strong one. The architecture is genuinely interesting, the efficiency claim is plausible and worth watching, and the coding numbers, taken as company claims, are impressive. But this is a launch analysis, not a hands-on verdict, because I could not run the model. The production cloud version was not live, and the open weights are too heavy for my setup. So treat the scores as Alibaba's own reporting. Expect a real test gate once the API is available, and judge it on work you can verify yourself, not on a launch table. The honest label is promising architecture, unverified capability, not yet available. Here is the takeaway I want you to keep. The flash framing makes this look like a budget model, but the real signal is more interesting than the price. 6 billion active parameters doing this much is an efficiency result, and efficiency is what eventually makes powerful models affordable to everyone. When this model actually ships and you can run it on your own hardest task, and compare it against the numbers in its own table, not the marketing around it. For now, watch the architecture, wait for the API, and treat every score as a claim until you measure it yourself.
Thank you for watching. Click here to subscribe. Click here to subscribe for more AI updates.